Good morning, students. Today we are going to discuss about the ionic product of water. As we know, water is a very poor conductor of electricity, but we can measure its conductance. That how it dissociate into its ion and electricity pass through the water. Here you can see self-ionization or auto-ionization. One water molecule and another water molecule in a medium. One water molecule will lose the H positive ion and another water molecule will take that H positive ion. So here you can see the one water molecule have taken that H positive ion and become H3O positive. And another water molecule which has lost its H positive ion becomes OH negative ion. If there is a one molecule, then here you can see it is dissociated into H positive ion and OH negative ion. The water molecule is ionized. If you are going to write the equilibrium constant expression, so you have to write product over reactant. The product are H positive ion, the concentration of H positive ion and the concentration of OH negative ion divided by the concentration of the water. Equilibrium constant for this reaction is 1.8 exponent minus 16 mole per dm cube. Volume is 1 dm cube. What is the concentration of water? So here we can calculate the concentration of water in this equilibrium constant expression. We can calculate the concentration of the water from its density. As we know, water having a density 1 gram per centimeter cube. So if we want to know this in a decimeter cube, so then it becomes 100 grams per decimeter cube. So here are the grams. As we know, moles is equals to mass over molar mass. So mass is 1000 grams and the molar mass of water is 18. So here you can see we have to divide the grams with the molar mass. That will be equals to moles divided by 1 because there is 1 decimeter cube. So no need to write it. So 1000 divided by 18, that will be equals to 55.55 moles per dm cube. This is the moles of the or the concentrations of the water molecule in 1 dm cube solution. So this is the concentration of the water that is basically in excess. We can consider it constant because this concentration of water is in a excess. So if the water molecule, if the concentration of the water is constant, then we can write it like this. Kc, this is the equilibrium constant expression. You can write it like this. The concentration of the water is in a division. On the other side of equation, it will be in a multiplication. So here you can see Kc multiplied with the concentration of the water molecule is equals to concentration of H positive ion and the concentration of the OH negative ion. This is the product of or the ionic product of water or the dissociation constant of the water. Here you can see these are the ions, H positive ion and the OH negative ion. So due to these ion, this is called as the ionic product. Ionic product of water is Kw. Kw is the ionic product of water, or this is also called as dissociation constant of water at 25 degrees Celsius. Temperature is very important in chemical equilibrium in this chapter. If the temperature change, the equilibrium constant, value of equilibrium constant will change. At a constant temperature, the value of equilibrium constant remains same as we have studied this. So put the values. Kc is equals to 1.8 exponent minus 16. The concentration of the water is 55.55 moles per dm cube. Multiply these values, it will becomes 1.01 exponent minus 14. Here you can see the ionic product of water having value 1 exponent minus 14 at 25 degree Celsius. By this we comes to know that the ionic product having value that is 1 exponent minus 14 at 25 degree Celsius. When the temperature changes, the value of Kw will be changed. Let's see the relationship between the ionic product of water and the temperature. In a neutral water, remember the concentration of H positive ion and the OH negative ions are always same. We are talking about the ionic product and the temperature relationship. Dissociation constant of water or the ionic product of water depends on the temperature. If you are increasing the temperature, the value of the Kw will increase. If you are increasing the temperature, the concentration of the H positive ions and the OH negative ions are increased. So if the temperature remains constant, if you are taking the fixed temperature, then the ionic product, the dissociation constant of water remains same. At 25 degrees Celsius, it having a value 1 exponent 10 ki power minus 14. Clear? If you are changing the temperature, here you can see at 0 degrees Celsius, Kw having a value 0.11 exponent minus 14. At 10 degrees Celsius, it is 0.30 exponent minus 14. At 25 degrees Celsius, it is 1 exponent minus 14. At 40 degrees Celsius, it is 3 exponent minus 14. And at 100 degrees Celsius, it is 7.5 exponent minus 14. So when you are changing the temperature, here you can see there is an increase of a temperature from 0 to 100. So there is an increase of the value of Kw, the value of dissociation constant of water, the value of ionic product of water. So temperature, if you are increasing the temperature, the ionic product of water will increase. Remember, always the concentration of H positive ion and OH negative ions in a neutral water is same. If you are increasing the temperature or decreasing the temperature, the ionic product will increase or decrease. But the concentration of H positive ion and OH negative ions are always same. Because one water molecule dissociate into H positive ion and OH negative ion, whatever is the temperature. Is 0, it's 10 degrees Celsius, it's 25 degrees Celsius, 40 degrees Celsius, 100. Water will dissociate into H positive ion and OH negative ion. So the concentration of H positive ions and the OH negative ions remains same in a neutral water. If you are taking a little bit acidic water or basic water, then concentration will be changed according to that. But in a neutral water, the concentration of H positive ions and the OH negative ions remains same. So, ionic product of water having value 10 minus 14, exponent minus 14 moles per dm³. As we said, the concentration of H positive ions and the OH negative ions remain same. So, which means if the concentration of H positive ion is X, for example X, then the concentration of OH negative ion will also be the X, because both having the same concentration. So I can replace this OH with the H positive ion. Yes? Okay. Is equals to exponent minus 14 moles per dm³. So I can take it square, because here you can see the two concentrations. So taking the square, 10 minus 14 moles per dm³. If I want to remove this square, so I have to take the under root. It will be cancelled out. The under root of exponent minus 14 will be exponent minus 7 moles per dm³ at 25 degrees Celsius. So this is the concentration of H positive ion when the moles of the water are 55.55 in 1 dm³. In that solution, the concentration of H positive ions remain same, that is 10 minus 7. But remember this concentration is same when the temperature is 25 degrees Celsius. If you are changing the temperature, then the concentration of H positive ion and OH negative ion will also increase. Concentrations will also increase. I only said that the concentration of H positive ion and OH negative ions remains same, because one water molecule will dissociate into H positive ion and OH negative ions. So how many molecules are dissociating? They are producing same amount of H positive ions and the OH negative ion at the specific temperature. But the concentration could be increased when you are increasing the temperature. The value of Kw increases almost 75 times, almost 75 times when temperature is increased from 0 degrees Celsius to 100 degree Celsius. There is no regular increase or decrease in Kw value, but almost 75 times there is an increase from 0 degrees Celsius to 100 degrees Celsius. Okay, in this way you have calculated the concentration of H positive ion. In the same way you can calculate the concentration of OH negative ion. So you have to change the here you have to change with the OH negative ion, because both having the same concentration. So in the same way you have to take the square of OH negative ion and the concentration, that is 10 raised to the power minus 14. So you have to take the square root. Square will cancel with the square root and it will be 10 minus 7. So concentration of H positive ion and the OH negative ions is exponent minus 7. By the addition of acid, concentration of H positive ion will increase. By the addition of base, the concentration of OH negative ions will increase. In a neutral water, the concentration of H positive ion and the OH negative ions remains same. What is pH and pOH? Let's talk about it. You have studied this in grade 10 that pH is the negative log of H positive ion concentration and pOH is the negative log of OH negative ion concentration. As we know, we are taking the less amount of water and the concentrations of H positive ion and OH negative ions are very, very low. So it is very difficult to calculate. So we get the idea of pH and OH to take the idea about the nature. Is the acid is strong, is the acid is weak, or is the base is strong, or is the base is weak. So if the solution is acidic, we have to calculate the pH. If the solution is basic, so we have to calculate the pOH, but not the exactly. Acids having also a pOH and the bases also having the pH. These are the scales to calculate. pH scale is from 0 to 14. At 77 pH, the solution is neutral. Below 7, the solution is acidic, and above 7, the solution is basic. In pOH scale, it is opposite. In pOH scale, 0 to 14, at 7, the solution is neutral. Below 7, that is basic, and above 7, that is acidic. In a pOH scale, in pH scale, 0 to 7 acidic and 7 to 14 basic. So for a neutral water molecule, as we know that H positive concentration of H positive ion and the concentration of OH negative ion is equals to minus exponent minus 7 moles per dm cube. So let's calculate the pH. pH is equals to minus log of concentration of H positive ion. Concentration of H positive ion is 10 raised to the power minus 7. So it will be minus 7. Power comes on the left side of the log. Minus 7 log 10. Minus minus plus. So plus 7 log 10 is equals to 1. So 7 ones are 7. So the pH is 7. In the same way, if you are going to calculate the POH minus log of OH, concentration of OH negative ions, so as we know the concentration of the OH negative ion is the same as the H positive ion, 10 raised to the power minus 7. So it will become 7. If the pH is 7, the solution is neutral. If the pH is less than 7, the solution is acidic. If the pH is greater than 7, then the solution is basic. Here you can see by the scale. If you are going to take the negative log of ionic product of water, then it will be equals to pKw. Here you can see pKw is the minus log of Kw. Let's see. As we know, Kw is the ionic product of water. Taking negative log on both sides, negative log Kw, negative log H positive and OH negative ions. Negative log of Kw is equals to, here you can see pKw. So negative log H positive ion concentration plus negative log of OH negative ion. These are in the multiplication. So when we have to apply the log, the value, the sign will be positive. When the something is in a division and you are applying the log, then value becomes in a negative with the negative. So pKw is equals to minus log of H positive ion is equals to pH and minus log of OH negative ions is equals to POH. So pKw is equals to pH plus POH. As we know, minus log of exponent minus 14. Kw is having a value minus 14. So it will become 14 here, log 10. Log 10 is 1. 14 multiplied by 1 is equals to 14. So pKw is equals to 14. pH is 7. POH is also 7. Here you can see pH 7 plus POH 7, that will be equals to 14. In this way you get this equation, pH plus POH is equals to 14. We have just generally memorized this, that pH plus POH is equals to 14, but now you know that how this comes. If you want to calculate the pH and you know about the POH, then you can easily calculate. POH is in a addition, on the other side of equation it will be in a multiplication. So pH is equals to 14 minus POH. In this way you can calculate the pH or POH of any of the solution. pKw value is less than 14 at higher temperature. If the temperature increase, Kw will increase, but the value of pKw will decrease. In acid with the greater H positive ion concentration, as we know, we are adding the acid, H positive ion concentration will increase. So the H positive ion concentration is increased, the acid is very, very strong because it dissociates completely into its ions. But the value of, let's see, for example, there are two acids, acid 1 and acid 2. Acid 1 having the concentration 10 raised to the power minus 2 moles per dm3, and acid 2 having the concentration 10 raised to the power minus 7 mole per dm cube. Which one is the stronger? This one, because this is the greater value and this is the lesser value. So more the concentration, more stronger will be the acid. But when you are going to take its pH, when you are going to calculate its pH, then the pH for this will be 2 and the pH for this will be 5, because you have to take the minus log of both of them. So if the pH is greater If the pH is greater, the acid is weaker. Acid is weaker acid. So pH is greater, the acid is weaker. pH is lower, here you can see 2 is the lesser value than 5. So if the pH is lesser, the acid is stronger. If the pH is more, then the acid is weaker. On the other side, if the concentration is more, here you can see 10 raised to the power minus 2 is higher than 10 raised to the power minus 5. Minus 5 is a smaller value as compared to minus 2. So the acid is stronger. In this table, you can see the pH or pOH. Basic solutions having a pH 7 to 8, 14 to 8, and at the 7, the solution is neutral. Below this 6 to 0, the solution is acidic. On the different concentration, you can see the pH. At the concentration 1 exponent minus 14, the pH is 14, the solution is basic. At exponent minus 13, the pH is 13, the solution is basic. Here you can see for water, 10 raised to the power minus 7, the pH is 7, and the solution is neutral. On the opposite side, you can see the scale of pOH. pOH scale, here you can see 0 to 6. 0 to 6, the solution is basic. In a scale, pOH scale, remember this, in a pH scale, 8 to 14, the solution is basic. At 7, the solution is neutral. 0 to 6, the solution is acidic. But in a scale of pOH, 0 to 6, solution is basic. At 7, solution is neutral. At 8 to 14, solution is acidic in pOH scale. In your book, there is another table, different materials and their pH and pOH. So just wrap this. You have to read this. 1 molar HCl having pH 0.1, pOH 13.9. Bread having a pH 5.5, pOH 8.5. Potatoes having a pH 5.8 and pOH is 8.5. Clear? Rainwater having a pH that is 6.2, pOH that is 7.8. Milk having a pH that is 6.5 and pOH 7.5. This is all about today's lecture.